Hello and good day in algebra. We are going over the answers to CO13 and then getting into CO14, which will look eerily similar to solving equations because we'll be solving inequalities, but there are a couple twists that we need to talk about for that. But first, we're going to look at how to interpret the verbal into an inequality, how to graph it, and things like that. So you must be 18 or older to vote. What symbol does 18 or older give us? What symbol? Yeah. Greater than or equal to. So I'm going to use A for age. You can use any variable. Really doesn't make a difference. But your age must be greater than or equal to 18. The other way to write that is 18 is less than or equal to A. Okay. The graph of both of these, though, is the same. It's showing that 18 is included, and then anything to the right of that is an eligible voting age. On your test for this objective, you're going to get 4 things just like this, to where you will need to write 2 inequalities and then graph it. Okay? So what you did for homework today is what you need to do on your test. Needing fewer than 8 strokes. I think we did this one yesterday. Maybe it was a different class. But in any case, the word fewer refers to less than. My S's look like 5, so I'm not going to use S for stroke. I'll use V for victory. V is less than 8, or 8 is greater than V. And then the graph of this is going to be 8, open circle, because 8 is not included here, and then it's going left. Weighing less than 210 pounds, less than, of course, would be that symbol again. So we have W is less than 210, or 210 is greater than W. Your graph, open circle at 210, going to the left. And finally, you can bring no more than $40 to the fair. What symbol would no more than represent? No more than. It's one of those kind of tricky ones. You have to think backwards. Less than or equal to, right? $40 would be the maximum. I think maximum and minimum were 2 words I forgot to add to our table yesterday. So back up to that table. The word maximum would be less than or equal to, right? Because that's the highest that you can go. And the word minimum would be greater than or equal to. Okay, so if you want to add maximum, less than or equal to, minimum, greater than or equal to the tables. But anyway, we'll use C for cash. C is less than or equal to 40, or 40 is greater than or equal to C. The graph in either case, closed circle at 40, going to the left. Okay? Questions on any of those? All right, next page, where you talk about some temperatures. The temperature tomorrow will be colder than -3 degrees. So T is less than -3, not less than or equal to, right? Because colder would not include -3. -3 is greater than T would be the other way to write that. And we have an open circle at -3 going left. The temperature a week from now will be warmer, I sure hope so, warmer than -12 degrees. T is greater than -12, or -12 is less than T. And so we have an open circle at -12 going to the right. Schools close if the temperature is -25 degrees or colder. That word or is kind of a clue here, right? Because you have less than or equal to -25 degrees or colder. So the temperature is going to be less than or equal to -25, or -25 is greater than or equal to the temperature. Either way, closed circle at -25, going left. And lastly, your parents will only let you go outside if the temperature is -10 degrees or warmer. So the temperature is going to be greater than or equal to -10, or -10 is less than or equal to T. -10, closed circle to the right. Questions on any of those? Okay. Can I do some foreshadowing here? You all know what foreshadowing is, right? Did you run into any, let's go back to the first page here. Which one I want to look at? Here we go. The most you can spend in the store is $20. I think we did this one in class. But the most you can spend at the store is $20. The graph for this should look like this. There's a closed circle at 20 going to the left. Did anybody find themselves having an internal struggle with that graph? If we're talking about the actual context of going to the store and spending no more than $20, Caleb? There's tax, which we would have to include in this, right? So if I walk up and buy something that's $19.99, I'm going to be in some trouble, okay? So that's a consideration. What else? Give me a number that is a solution to that graph. Blake? But by solution, I mean, what is a dollar amount that this graph represents I could spend when I go to the store? Not how to get 20, like you said, but like, is 18 part of that range? Is 18 less than? So I could spend $18 when I go to the store, right? What's another solution? Another possible dollar amount that this graph tells me I could spend? $5. Right? 5 is over here somewhere. What else? That's a horrible looking 5. Whew, not sure I fixed it. Peter? $15 is in there. Blake? Oof. That's a problem, right? I have never gone into a store and walked out with more money than I started with. You tell me how to do that, and we can be best friends for life. Okay? But technically, a number that is less than or equal to 20, negative 10, would be a part of that, right? So there is something kind of wrong with the graph that we have here, because not every number less than or equal to 20 is a solution to this. We have another kind of endpoint here, right? 20 is kind of where values start, but what's the end of this range, the other end of it? Blake? Zero. Never walked into the store and spent nothing. Tell me how to do that. But yeah, right. Okay. So there's a little flaw to these graphs when you consider the context of the question. But luckily, mathematicians have thought of that, and we'll come back to this when we get to CO16. But for now, if you did kind of realize, hey, wait a minute, that's not exactly right, you were good to think it, and it is accurate that there is kind of another limit to this, but we'll get to that later. Okay, then you needed to interpret the graph. So you needed to write 2 inequality statements that represented the graph shown. This first one, whatever variable that you want to use, n is greater than 11, or 11 is less than n. The next one, n is less than 4, or 4 is greater than n. And when I say or, you do need them both, but it's the other way to write it. For this one, n is greater than or equal to negative 4. Negative 4 is less than or equal to n. And lastly, n is less than or equal to 6. 6 is greater than or equal to n. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms on this? Blake? Thank you. When I'm not actually writing words, I tend to do okay because I don't string my letters together in printed cursive. But thank you. I'll accept the compliment. Anything else? All right. Onward we go then to CO14. CO14, solving two-step inequalities. Okay. And if we replace the word inequalities with equations, you already know how to do this, right? You know, how do you solve a two-step equation? Opposite operations, move the constant over, divide by the coefficient, right? Back to P09, okay? And the process for inequalities is really the same thing. You'll have a constant, you'll have a coefficient, you're using opposite operations, you're moving the constant over, you're dividing by the coefficient, none of those things change, okay? But the two differences, right? Number one, which one I want to go first here? Okay, this first one is kind of the big one here. When your coefficient is negative, okay, and you multiply or divide by that number. So when you multiply or divide by a negative coefficient, the inequality sign switches. And we'll talk about why that is in just a bit, but that's number one thing that you need to remember when solving an inequality instead of an equation. That when you multiply or divide by a negative coefficient, the inequality switches. When you multiply or divide by a negative coefficient, the inequality switches. And the second thing, in an equation, you get one value for the variable, right? N equals 2 or N equals -8, right? That's just it. It can equal one thing. In an inequality, N is less than 4. There's a whole bunch of stuff, right? It could be 3, it could be 2, it could be 1, it could be 0. So the second thing is that you must graph your solution. And we practice graphing solutions in the last objective. Make that number line, open circle, closed circle, put the arrow in there, right? So we've already done that part. But because it's an inequality, the solution must be graphed. Okay, so let's scroll down to these first few examples here and practice that first rule, okay, and talk about why. So this first one here, -8n is less than 80, okay? Think about where 80 is on the number line. It's greater than 0, right? It's on the right side of 0, correct? Right? And if we want to, we're looking for the left side of this inequality to be on the left side of 80, the 0 side of 80, right? Does that make sense? The 0 side of 80, you know? If -8n is less than 80, if we think about where 80 is on a number line, less than 80 is over there. It's on the 0 side, okay? In order to solve this, though, we're going to have to divide by that coefficient. And when we divide by a negative number, what happens to that 80? When we divide 80 by -8, what happens to that 80? Drew? It becomes a negative. 80 divided by -8 is a -10. And because we've switched the side of the number line that we're on, right? We were talking about positive 80. Now we're switching the side of the number line that we're on the negative side. Because we still want this to be on the 0 side, we have to change our inequality as well. So n becomes greater than -10. So if you think about where -10 is on the number line, right? We want to be on the 0 side of that. That's going to be on the right side of -10. So because we're switching sides of the number line, when multiplying and dividing, that inequality symbol must switch. So we still have that same kind of relationship there. So when we graph this, n is greater than -10. It's an open circle because it's just greater than, and it's going to the right. Okay? But it goes back to that when we multiply or divide by a negative number, because the side of the number line that we're on, the side of 0 we're on, switches, okay, the inequality symbol must switch as well. So do we need to change our inequality sign in the second one? -7n is less than or equal to 35. In the process of solving this, are we going to be multiplying or dividing by a negative number that's going to cause that solution side to switch? We are, right? To solve this using opposite operations, since we're multiplying n by negative 7, to undo that, we're going to be dividing by negative 7. And dividing positive 35 by a negative 7 causes that sign to switch. We're going to get a negative 5. Okay? So instead of less than or equal to, it's now greater than or equal to. Because we switched the side of 0, switched the side of the number line, we switched the inequality symbol as well. And so n is greater than or equal to negative 5. Close circle, going right. Okay? The next one. N divided by 3 is greater than or equal to negative 6. What's the one step that we need to do here to solve for n, get n by itself? What are we doing to n? How do we undo that? Multiply by 3. Notice what happens here when we multiply both sides by 3. Right? On the left side, the 3's cancel out. We're left with n. That's why we multiply by 3, to get n by itself there. But on the right side, negative 6 times 3 is what? Negative 18. Did the sign change? Did we switch sides of the number line? No. That negative 6, nothing happened to it, except it became negative 18. But because it's still a negative, the inequality sign does not change. It is only when you multiply or divide by a negative number. Okay? We are multiplying negative 6 by 3. 3 is positive. The sign of our solution side didn't change, so the inequality symbol doesn't change. Right? Some folks think, you've got a negative number involved, therefore it's got to switch. Not necessarily. It's what you are multiplying or dividing by. And we are multiplying by positive 3. The last one there. N divided by negative 4 is greater than negative 36. To get that n by itself, we're going to be multiplying by what? William? Negative 4. We are multiplying by negative 4. Is my solution side, is the sign going to change there? Negative 36. Is that going to stay negative or jump positive? Jump positive. Therefore, do we flip our sign? Yes, we do. Okay. What's 36 times 4? 144. And is less than positive 144. Right? So the only one that we didn't flip our sign in these examples here was this third one. And the reason why was because the number that we were multiplying by, that 3, was positive. When we divided by a negative, we switched. We divided by a negative, we switched. We multiplied by a positive, we multiplied by a negative, we switched. Okay? Does that make sense? I call it the red flag when solving inequalities. Okay, so let's look at some examples here. You hopefully recognize these as two-step equation setup, right? You've got your coefficient, you've got your constant, you've got your symbol, and you've got your solution side. So 7n plus 3 is less than 17. What are we doing first? First opposite operation step. 7n plus 3 is less than 17. Caleb. Subtract 3, right. Start with that constant. Okay. The constant, I don't have to worry about switching the sign ever, because when I deal with that constant, I'm not multiplying or dividing, right? I'm adding or subtracting. Even if I were to cross over 0, that doesn't make a difference when you add or subtract. It's only with that multiplication or division. So we have 7n is less than 14. Divide by 2, or divide by 7 To get to, do I flip my inequality symbol? I do not. I started with positive 14. I end with a positive 2, and n is greater than 2. Because it's an inequality, this needs to be graphed to show that any number, what did I do? Did I? It sounds like I really knew how to edit these videos, because now I just look like an idiot to the 4 people that actually watch them. Okay. So anyway, thank you though. So I could change my graph now too, don't I? Oh, brother. So n is less than 2. And you know what? What I was about to do, I was about to say, how would you check the answer here? So I would have caught myself, which is why you should be checking answers also. But any number less than 2 is going to make this inequality true. Violet?
I'm wondering, why is it equal to? Because isn't 7 times 2 14?
Yes. So the reason why is because what we're looking for initially is we're looking for a value for n that makes this less than 17. What value for n makes our left side less than the right side, right? And so it's not equal to 2, because if n were equal to 2, then 7 times 2 is 14 plus 3, that'd be equal to 17, which is not less than 17. However, any number less than 2, we'll pick 1. 7 times 1 plus 3 is 10. 10 is less than 17. So it satisfies what the inequality says. Okay? It goes back to, what do inequalities do? They compare, right? The left side is less than 17. Questions on that? That was a good one, thank you. Okay. The next one, 12n minus 18 is greater than or equal to negative 66. First step in solving this. Opposite operations, undo what is being done.
So first off, you would take negative 18 and add it negative 18 and
Right. Since we're subtracting 18, start with that constant. The opposite of that is adding. We're going to add 18 to both sides. We don't even think about any sign flipping, because with your constant, it'll never happen. Negative 66 plus 18 is a negative 48. Second step, divide by 12. Are we flipping our sign? No, and I won't do it either. And we're not flipping because what we're dividing by is a positive number. We're dividing by positive 12. That negative 48, the sign of that didn't change. It's still negative. So the sign doesn't change either. So n is greater than or equal to negative 4. Closed circle, oh brother. Closed circle at negative 4. Going to the right. And so any number that you were to pick that's right of negative 4, greater than negative 4, is going to make this work. I always like to test 0 because it's super easy, just to plug a 0 in, okay? Because it essentially cancels out that first term, because anything times 0 is 0. So that's gone. Is negative 18 greater than or equal to negative 66? Yes. And so it works. Okay. The last one, negative 8n minus 2 is less than 22. First step, we're going to add 2 to both sides. Negative 8n is less than 24. Second step, we're dividing by that coefficient. And what do we got to do? Red flags going off in your head, bells, whistles, sirens, horns, right? James? We're dividing by negative 8, and because that 8 is negative, that inequality symbol is going to flip. Because that 24 went from positive 24 to a negative 3. We jumped sides on the number line. We're dividing by a negative 8. And when you do that, when you divide by that negative number, the inequality symbol flips. So n is greater than -3. Open circle at -3, going to the right. Any number in that range is going to be a solution. You with me? We good? Or at least we're within earshot, if maybe. No? Laura? All right. Okay. So the second page, very similar to the first. You've got more two-step equations to work on here. And then you've got some word problems. 2 of them or 3 of them? What do we got? 3 of them to work on here. So we've got about 5 minutes until I got to let you go to start getting ready for lunch. So what is one of these first 6 you would like to discuss together? Any of them stand out as particularly, Michael?
The fifth one.
The 5th one, the 9n minus 30?
Yeah.
Okay. What about that one?
I just want to know how to do it.
Okay. So 9n minus 30 is greater than or equal to 15. We first look at what's being done. We want to undo it. We're subtracting 30, start with that constant. So our first step is going to be add 30. So again, 9n is greater than or equal to 45. Now to undo multiplying by 9, we're going to divide by 9. Flip our sign? Nope. We're dividing by a positive. So it stays greater than or equal to, which our graph is going to be a closed circle at 5, going right. Okay? That one quickly. Another one. Peter. The first one. N divided by -2 plus 5 is less than or equal to -3. Our constant there, that positive 5, always start with that. So subtract 5 from both sides. That gives us n divided by -2 is less than or equal to -8. Second step, we are dividing n by -2. So to undo that, we're multiplying by -2. Sign flip? Yes. Multiplying by -2 is going to change that -8, change the sign to a positive 16. Right? And because that sign changed, our sign changes as well. It was originally less than or equal to. It's now going to become greater than or equal to. And so we get n is greater than or equal to 16. Right? And the reason why is that, if we're less than -8, that's going away from 0, right? Think where -8 is on the number line. -8 is here, 0 is here. If we're less than that, we're going away from 0. So when that flips the positive side, we also have to be going away from 0. So think of where 16 is. Here's 0, here's 16. We've got to be going away from 0. If we kept our symbol less than or equal to, we'd be going towards 0. It's not what's happening here. We're going away. Okay? So it's going to be a closed circle above 16 going to the right. That's why we switched that sign, to keep that relationship going. Yes? -12 minus 5n. Yeah, so this one is not me really trolling you necessarily, but I rearranged the order of my coefficient and my constant. Okay? You're still going to start with that constant, which is the number without the variable, in this case, -12. Right? So you're still going to start there and do the opposite of a -12, which is adding 12. Don't forget about that sign on the -5n. It's still -5n. And do I change my sign because that -2 is now a positive 10? No, because I did it with addition. It's only when you multiply or divide is when that sign change results in an inequality flip. Right? Now, it turns out I flipped my sign anyway because I'm dividing by -5 now, which dividing by that negative is going to cause it to become a less than symbol. and we get n is less than -2. Okay. All right. We didn't get a chance to really go over the word problems there, but the added challenge here is you need to write the inequality yourself. Caleb?
On the last problem, you go from, at first it goes 11 minus 14, which gives you -3, then times -7 and brings you back to positive 21. Do you flip the sign still?
You would.
Okay.
Anytime that you are multiplying or dividing by a negative. Okay. So just very quickly, these word problems down here. The first one, you and 3 friends decide to go in on a 15-book series. The 4 of you can spend a total no more than 212 and plan on dividing the cost evenly. Use a graph to describe the cost per book the 4 of you can afford. Okay, so the 4 of you are going in on this series together. You're going to do the total cost. You're going to divide it evenly among the 4 of you, and no more than $212. So here's a hint. So your solution side should read less than or equal to 212. Okay, and then your goal here is to create a graph to describe the cost per book that the 4 of you can afford. Okay, it might be borderline multi-step. Blake? The cost per book. So of the 15-book series, what's the cost per book that the 4 of you can afford? Not individually, but total. Yeah, yeah. Okay? And then you have a couple others too. All right, that's how you math, folks. Homework due tomorrow.